Well, this is the first one of these I've ever done, so we've got to allow for some stuff-ups. Okay, well, the story goes that I started my apprenticeship at BWD Electronics in 1976. 66, let's get that right, 66, when my first wages was in pounds, shillings and pence. And I think from memory it was £6 and 17 or something. Anyway, it was a really nice place to work at, and you know, everybody was very, very friendly. The majority of people in the company were all Poms, except for me. I was the only Italian, I think, in the whole place. And it was, you know, pretty good. We used to have a tea lady that used to come around at 10 o'clock and give us a biscuit and give us a cup of tea or whatever we wanted. And so that was the way it went. And then one of my first jobs that I got there was on the production line. I had to fill up all the little sponges with water for the girls that were doing the soldering. Then I got promoted to emptying the rubbish bins, so that was pretty good. And later on after that, I got another promotion where I used to stamp the chassis. We used to build this power supply called the 215, which people might have, which have 4 6CA7s as series regulators. And I had to go around with a rubber stamp, dip it in the ink and go V1 6CA7, V2 6CA7. So we had plenty of these little jobs, and we even had things like selection of resistors. BWD didn't have a lot of money, so they used to like getting their resistors and selecting them. Things like if they needed a 990k resistor, they got a 1 meg and they put it into we had a digital multimeter which was made in France by a company called Tech. And we used to put them in, and the girl would measure 990k, and then she'd get some paint. You know, those little paints that you get for doing model aeroplanes, and put a white stripe across it, which meant that was not a 1 meg anymore, it was a 990k. We also used to select 10.1k resistors, and that was a 10k with a black line across it. And then we also used to select capacitors. They used to use those green caps, and a little white dot meant that it was a white % one, and a little red dot meant it was a 2% one. Then a couple of other problems they used to have was FETs. FETs have very, very wide tolerances, or the ones that we used to use, MPF 106s or 2N3819s. So there was a little jig that I made, that John Beasley designed, and you put the little FET in there, it would give you some sort of reading, but I never knew what this reading was, but it was something called VDS. And then they used to put little dots on them, depending what the VDS was. And the reason they did that is, I don't know how this marker thing's going to go, but here we go. We'll try this black thing here. Now, I'm no design engineer, of course, so some of the things I could be telling you could be a lot of hooey. You'd have an FET there, followed by a transistor there, 2 more transistors in here. That was the supply rail plus. That was down there at earth minus. And at the output stage here, you had to have half supply rail. So if you had 10 volts up there, you needed 5 volts here. But this FET in here was very important, which had a resistor in its source. Now, if you weren't anywhere near what you had to be, sometimes I'd also have a little tap on that. And if you weren't in the right range, you could not achieve this 5 volts here. Or if you had a positive and negative supply, you'd be aiming for a 0 in the middle. So then what you'd do is you'd wriggle this little pot until this was achieved. Otherwise, what was going to happen is, when you put a sine wave in there and it's DC coupled, it would go up to there, flatten off, and then it wouldn't go down to 0. Or if it was wrong, it would go the other way. And unfortunately, there was plenty of these things that went into different places. Where's my bit of paper? Okay. Another little job that I got was the trigger pots on the oscilloscopes was 100K A. And what we had to do with it is when the wiper went around fully clockwise, it had to go open circuit. So someone worked out that if you mixed up a bit of aril, pulled the pot to pieces, got the little wafer out of it, and you could put a little dob of araldite on it, let it set, and then put the pot back together again. Well, of course, that was my job. Then there were power transistors. We used to select the 2N3055s. Most of the transistors we used to use in the beginning were RCA ones. They were really good, but they cost money. And as an apprentice, I used to like to cut things open to see what was inside them. So when I used to cut a 2N3055 to pieces, it had a nice big piece of silicon in there, about 1/4 of an inch. Then later on we got Fairchild ones. Well, they were absolute rubbish. When I'd cut those ones over, it was a 1/16 of an inch piece of silicon. Then someone decided to go to Motorola ones. Well, they were rubbish as well. The reason being was they were an aluminium case. And when they stamped the lid on them, or they welded it on or whatever they did, it bowed. So if you put a straight edge underneath it, you could see daylight. And of course the problem was when you were trying to put some amps through it, it used to get hot, but the heatsink was cold. Where are we up to? Other little things that were done were MJE 340 transistors. They had a little white dot on the top. That meant they had a beta greater than 50. So if you pull a BWD thing to bits and it's got a little white dot, beta greater than 50. Then delay lines, they started to come in. Now, of course, delay lines were very hard things to get. So one of my jobs was to wind them by hand, but it was only for prototypes. And I think the first one took me about 4 hours to wind. It was about 1 metre long, and it was wound on a piece of 300 ohm ribbon. And I was just told that one wire goes clockwise and the other wire goes anti-clockwise. After that, we made another one which was wound on fishing wire with real thin enamelled wire. That took me 2 days to wind. But the results were getting there. So then what happened is with all the delay lines, we used to buy them from England, from Advance, the oscilloscope people, or people that make test equipment in England. And what my job was, they were too long for our oscilloscope, so we had to chop 6 inches off them. And of course, because they were braided and the wire was thin, I was able to peel the wire off, the curly wire off the outside, leave a little bit of the fishing line that was in the actual core of it, and then terminate 2 wires on and put heat shrink all over them and get them ready for the production line. Where are we up to? 6 DJ8s. Now, BWD used to select all their 6 DJ8s because apparently in the front end of the oscilloscope, you need the valve to be a matched valve. The 2 halves of the triad have got to be matched. So what my job was one day, of course, John Beasley designed it and I built it, was a valve soaker. So I used to have about 36 DJ8s plugged into this thing, and we'd let them run for a whole week. Then they'd go along and measure the cathode voltages. So all the ones that had like 0 across the cathodes got a little red dot across them. And that was the selected one that went into the input stage. All the ones that didn't get the red dot were in the output stage. Then later on it became a little bit hard to get 6 DJ8s. So somebody designed a solid state one. It was called 511V1, 6 DJ8. And I built that back in 1974. That was the wiring copy for the other girls on the production line to build. Okay, where are we up to? Another job that I was good at was writing parts lists. John Beasley used to give me the circuit, and you go along and write V1, 10K, V2, whatever it was. And then when you'd finish, you'd say 30 10K resistors, because it had all the resistors down one side, like, you know, from 1 ohm to 1 meg or whatever it was, and you'd say a 10K, a 5K, or whatever it was. And then when the units, one John Beasley used to design the oscilloscopes, he would give it to me. He'd say, now pull it to bits and make it good for production. So I used to make the loom board up, which was a piece of round wood, and you'd have hundreds of nails all over it, and you label the numbers. Number 1 to number 42 was 230076 black, which was the mains wire, and the other one was the red one going to pin 2 to pin 43, and then there was the green one, and then of course you'd have to lace them all up. And I made some looms recently but forgot to bring my loom board, and I hadn't made a loom for 50 years, and believe it or not, I hadn't forgotten how to do it. Somebody said it was like riding a bicycle. Okay. Now, most of the oscilloscope wiring copies were all built by me. I don't know how come I got volunteered into this, but they reckon my soldering was good and I could do them really well. So here's one over here that still has my writing on it. This one here. This was the most expensive plug-in they made. It was about nearly $700. But it's 10 microvolt sensitivity, and it was made for the medical people. And it's very, 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 very complicated. In fact, it wasn't designed by John Beazley. That's about the only thing that wasn't. Now, I've got some leaflets here to give out on John Beazley, which is that, his story. And on the back, it's got the circuit of the 6DJ8, the equivalent. So everybody's welcome to have one. Now, the other thing I used to do was, before instruments went into production, I used to build the first 5. Since I'd written the price lists and done all the other stuff, they'd make a kit up of 5 units and I would build them. Now, if they worked, that was great. If it didn't, they went to John Beazley. It's your job. You designed it. You fix it. But unfortunately, I probably should have changed the story a little bit here. In the beginning, when I went there, after about 6 months, I never knew who John Beazley was because he was away on long service leave. And he was the man in the white coat. So anyway, one day he comes out to see me. I said, "What have I done wrong?" He said, "I believe you know something about electronics." I said, "Not really." He said, "Well, I've made these plugins which don't work. And the PMG at the time, as it was known, were coming to buy them and to check them out that they work." He said, "Do you think you could cut this track and this track and this track, remove these transistors, put these transistors in and do this and do that?" I said, "I'll give it a go." So anyway, I did exactly what he told me, and they all worked. So the next day, John Beazley went to the production manager and said, "Sorry, mate, you've lost Charlie. He's coming into the lab with me." So that's how come I ended up in the lab. Now, another thing BWD had was when they used to transport their oscilloscopes to Sydney or around Australia on the back of a truck, when they switched them on, the tube was always crooked, as one of my ones is on this one here. So somebody designed a vibrator, which had a big weight in it that went around and around, and you tied 2 of these oscilloscopes to it, and then you found out all the nuts and bolts that came loose and how much the tube twisted around. So then they worked out ways of making another bracket on the bottom of the power transformer so that it didn't shake around. In BWD circuits, you'll find a lot of 10 ohm resistors and 33 ohm resistors, and they're mainly there to use as links. Because believe it or not, a resistor was cheaper to buy than to making a link, because by the time the girl got a piece of copper wire and tin copper and she stretched it and she bent it, it was very time consuming. Where you could pick up a resistor and just go and it was bent and into the hole it went. But it was also a good protection, because if you had a little tantalum after it and the tantalum shorted, the 10 ohm resistor would get hot. So you'd say, "Aha, that's the one that's failed." Oh, another job that I used to do before I went into the laboratory was the knobs. I used to drill the knobs and tap the knobs and paint the little white line on them. And that went on for days and days, and it was bloody boring. Then later on, when they started to build the oscilloscopes, we found things that, since all these oscilloscopes are all direct coupled inside, and they're all a differential amplifier, one of the inputs goes straight to the terminal at the front. The other input has to go to ground. But where you ground this is very, 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 very critical. And there's no way of determining where it is. You've just got to play around with it till you find a good spot. So when you display a 1 meg square wave, you don't get too much ringing. So that was one job. You'd be sitting there trying along here and earthing it there and doing all sorts of things. Now, oscilloscopes have got something that they call input capacitance. You'll notice on the front they're all 1 meg ohm, or all BWD ones are. And some of them are like 33 puff input capacitance. Now, if the capacitance isn't the same on all the attenuated positions, when you put your by 10 probe on it, it won't be compensated. Now, I don't know if you know much about How do you clean this board? Anyway, a square wave looks like that. Now, if the probe is not compensated or overcompensated, you'll get this. If it's undercompensated, you'll get that. And it's important that on every range that you've got, you end up with a square wave if it's set correctly. But if it isn't, it means that the input capacitance has changed, because every range, there's about 3 capacitors that you set for input capacitance. And if they're not right, of course, that will happen. Now, where are we up to? A by-10 probe. Why do you use a by-10 probe? The most important thing is that it divides the input capacitance. So when you look on the oscilloscope and it says 33 puff input capacitance at 1 meg, when you put a probe in there which is 10 to 1, that reduces the input capacitance to 3 puff, to 3.3 puff. Because on most things, if you hang 33 puff across, say you're working on your radio and you look at the IF 455, as soon as you put the probe on, it stops working. But if you put 3.3 puff on it, it might still work. Because if it's got a 100 puff tuning capacitor, the 3 puff is only 3% of it. Now, the other thing that BWD used to get in trouble with, to reduce the wiring on oscilloscopes and things, you've got your controls up the front, but a lot of the stuff comes from the back. So you've got to run wires all the way from the front to the back. Then John Beasley decided to put the pot down the back, which saved in all the wiring. But the problem you had there is all these brass rods that went from the back to the front became resonant lines. So you had to go along and earth them. You had to make up little straps to earth them. Then later on, they went to fiberglass ones, so that overcame that problem. We're running down here. One little thing that I came up with was when we used to build the attenuators, the original ones we used to have in, the trimmers were all screwed in. But then they found some cheaper ones that you soldered in. And of course, when you're soldering them onto a bracket, you need a lot of heat. The poor old scope soldering iron is really, really working overtime. And when you look at the job that you've done, it's a real bloody mess. So I come up with an idea of getting a 1/4-inch drill, winding some solder around it, cutting them all into little circles, putting the little circles on the trimmers, putting them upside down, and then heating up the bracket with one of those flame thingos, and the solder would melt, and it looks beautiful, and there's some of them there. And also they have a mica capacitor, which is used on the lowest range, and it's very, very important to have the lead as short as possible. So that gets soldered directly to the chassis. You can have a look if anybody's interested. And if anyone's got any answers, stick your hand up. Sorry, any questions? I hopefully might have the answer. Right, this is slowly running down. Now, oscilloscopes, the plates leads that go from the output stage to the plates is very, very critical. The shorter they are, the more bandwidth you're going to get. And unfortunately, with some of the oscilloscopes, they have little things inside, like little tags that you put the wires through to keep them parallel. The very, very early ones on the valve one, they used to use 300 ohm ribbon. So, yeah. And John Beasley used to say, if every time you can half the anode load or the collector load, you can double your bandwidth. But there's only one disadvantage with that, it also halves the gain. Oh, the other thing they had to do too was when they had these rods going all the way up the front, if you sort of wriggled them around and they touched earth and, made contact, you'd see your square wave doing all sorts of things. So they had to use little insulation bushes on all of them. We'll come to that one. Right. Now, the way you check bandwidths is you can check them a couple of ways. Good oscilloscopes will tell you that you display 6 centimetres, wind up the start off with a 50 kilohertz reference and set up 6 centimetres. When it drops to 4.2 centimetres, that's the 3 dB point. The cheaper oscilloscopes, they tell you to do it to 4 megs, to 4 centimetres, and when it drops to 2.8, that's the 3 dB point. Now, in some of the BWD oscilloscopes, the later model ones, The collared wires will tell you what voltage is on them. John Beasley came up with a method that black was 0, yellow was plus 15, purple was minus 15, red and white was 6 volts, red by itself was 110 volts, white was minus 50. I forgot what colour plus 50 was. Anyway, so if you went around to a wire, it was a red wire, it was going to be plus 110. A yellow wire, plus 15. So that was a good idea. Now another little thing, I used to build subcontractor BWD, the 17-inch oscilloscopes. They were the ones that people used at the colleges. And I used to get $10. Now, they used to build all the sub-assemblies, and I used to stay back after work because there was a couple of different versions. Some of them you stood around the front to operate them, where you were in front of the screen. Then they had some other ones where you hopped around the back, and they had a small little display CRT at the back where you could fiddle and the students could see what was going on there. And then the story goes with the power scopes. Now, John Beasley designed the power scope. He got an award from Prince Philip for excellence in design. And the way it came about was he went to the SEC, as it was in those days, and they had 3-phase with 3 big SCRs and a Tektronix oscilloscope connected to them. And one guy was saying, turn the knob. And the other side said, buggy, it's got 415 volts on it. He says, we'll use the broom handle. So John Beasley thought, I know, I can make a plastic front panel, insulate all the knobs. And he was the first man to do it. And that was the BWD 880. Then later on they made a BWD 881, which had 4 of the inputs were for 3-phase use, but then it had another input that went to 50 megs, because the 3-phase units only go to about 8 meg frequency response. And that's about it. There's not much more I can tell you. Except I've got a list here of all the models that they made. I don't know if you want me to read them out, or anybody interested?
How many people do you reckon worked there?
There was about 32. No, it wasn't a very big company. Yeah, and John Beasley did most of the design, and unfortunately he wasn't even a design engineer. He was only just a draftsman, but he had this knack for doing things, and whatever he did worked. Then later on, when we started building stuff for the Navy and the Air Force and all these other people, you'd have all these colonels that would come along with electronic engineer, member of this, a member of that. So, of course, John Beasley couldn't even talk to these people. So he got other engineers in, but they were all bloody hopeless. They had the letters after their name, but they achieved nothing. I had one guy that came to me once who was working on a double balance mixer. He was an engineer. He came to me with a 10K resistor. He said, Charlie, what value is that resistor? I said, what do you mean, what value is it? He says, I don't know how to read resistors. I said, it's a 10K. He said, how'd you work it out so quickly? I said, I could pick a 10K resistor in a box of, a couple of hundred in just like that. But these people couldn't do anything. Then changing the subject, when I left BWD, I went to work for a company called Electronic Engineering that were a division of Astor. They were in Huntingdale Road. And there was one guy there, I won't quite mention his name. I'll tell you his first name, it was Ian. And he was working on the Radioson. The Radioson used to be made with a valve, a 3A5. But one day they received a letter from Eveready saying, we're not making 45 volt batteries anymore. So his job was to redesign it to run on a transistor. So he had one transistor, a cavity, 3 resistors and 1 inductor and a 9 volt battery. And I was there for about a year and a half, and when I left, he was still working on it. And John Beasley would have done about 4 oscilloscopes by then. So that's about it. If anyone has any other questions. Yes?
Where was BWD based?
Originally, when they first started, they were at number 67 Burwood Road in Burwood. They were there for a couple of years, and then they moved to 313 to 333 Burke Road, Gardner, which is right where the freeway is. And I had a really good spot where I used to work because I could look out the window and see Gardner's Creek. I could see the water flowing. It was beautiful. Then after that, I'd left, but then they moved to Mulgrave, to 2 places in Mulgrave. They went to Miles Street in Mulgrave, and then they went to Getty Street in Mulgrave. And then they moved again, and they changed their name, because they had a few name changes in the meantime. Because unfortunately with BWD, it was a bit of a funny company because they made stuff for the government. You didn't get paid after 60 days that you delivered the goods. So unfortunately, they were borrowing money from the bank. And of course they had to pay it back. And I think what must have really got them when interest was about 18%, that sort of put the nails in the coffin, I think.
When did they finish? What year?
Well, they've had a couple of name changes. Actually, they were BWD Electronics when I was there, but then they became BWD Instruments. And then when it all failed, there's a guy called Bob McPherson, which some people might know, because he used to work for Astor. He was the production manager. He ended up buying the company, him and another guy. Then they called it McVan. And it went for a few years under McVan, and then they changed it to Observator. And they're still going, but they don't make anything. They buy stuff from overseas, have a look at it, and on-sell it. Oh, I probably forgot to tell you, when BWD closed up all the way, I ended up buying all their parts. So in the meantime, I am building some of their oscilloscopes. These ones here, I'm building 14 of them out of spare parts. And another model, I'm building 12 of them. Because the other thing I'd like to do is thank Rockby Electronics, because he gets me all the bits, the resistors, the capacitors, the transistors, because a lot of the boards were just blank boards. So if you need anything, Rockby's a good place to go to. Anyway, so out of the oscilloscopes, they ended up making about 50 different models in the time that I knew them. Then they made about probably 15 lots of power supplies. They probably made another 20 lots of oscillators. And then they also made this thing called Electroflux, which was used for testing crankshafts. Now, I had nothing to do with that, except I made a couple of the little timers. They were 25-second timers. And apparently you stick a crankshaft in it, the principle that it works on, and you put 500 amps through this crankshaft. And then there's this special spray with iron filings or something in it. You spray it over the crankshaft, and if it's got a crack in it, it'll become a positive and a negative. And I think it used to cost about $10,000 when I was there. But it was a big unit, it was 10 foot long. Anyway, well, that's about it from me. So if anybody else has any questions, I have another question. Go.
Yeah, Charlie, just any observations about either the reliability or performance of a valve-based oscilloscope versus solid state?
Well, the solid state ones are probably better because the valves got old. Transistors don't get old. They either blow up or they keep working. The gain never changes. It's always the same, or very seldom do they go leaky. Anything else? Oh, we have another one.
Did you get caught with any warranty big problems or
Yes.
bad batches?
Yes. What happened is all our meters were made in Sydney by a company called Master Instruments. And one day they decided to paint the pointers red because they used to be white or black. And about 2 years later, all the pointers fell off because the paint that they used attacked the aluminium pointer. That was about the only really disaster they had. I know occasionally they had some of the oscilloscopes, the early ones, the 550 volt winding used to fail. But then, the oscilloscopes now are 40 and 50 years old. The other thing is too, is with the number of the oscilloscopes, if something is called a 301, it means it's got a 3-inch screen. If it's called a 509 or 50, it's got a 5-inch screen. But then later on, as they got a bit sort of more into it, they changed the number to 8. And the 8 meant 80s. So an 820 was something built in the 80s. Yeah, so that's about it. I can't think of it unless someone else wants to ask me some more. Here we go.
The crow screws themselves last for, Charlie?
Well, it depends. If some of the people leave them switched on all day long with the intensity really bright, it'll burn a hole in the phosphor.
No, if they're looked at, like used normally without doing anything untoward.
40 years.
40 odd years.
Oh, that's another thing I was going to say. I fixed quite a few Tektronix oscilloscopes. Now, there's a company in Canada called Sphere Electronics, and they sell second-hand CRTs for some of the Tektronix oscilloscopes. And they always write down, filaments check okay, filaments check okay, filaments check okay. I have never, ever seen BWD, or they're Philips, most of the tubes, ever open circuit. But then about a couple of years ago, I brought 4 Tektronix oscilloscopes, little plug-in ones. They're called a 500 series. 6 of them. The whole 6 have got open circuit filaments.
You say they made a storage crate?
They did. I didn't bring one along. They only made one. It was called an 845. It looks exactly like that one.
Right.
Because the tech storage crows used to pop their filaments all the time. They were shit things.
Well, the other thing about BWD stuff, it's very, very easy to fix. You know, like when you work on them, you can pull out, the most things that would go wrong would be the EHT supply. So, of course, but you can pull that out. You can work on it on the bench. Yet if you try to fix a Tektronix oscilloscope, like a 465 or a 475, and you've got to replace the EHT transformer, mate, it takes about a week. You've got to pull all the oscilloscope to bits. You've got to pull all these boards out before you can even get to the thing.
But it doesn't happen. It doesn't happen often with them.
It does happen though. But the time that it does happen, you wish it didn't happen to you. I've had to do a couple because apparently the varnish goes off a bit, and the varnish that they pot the core with. Anyway, I need some more. Here we are.
What brand of test equipment did the company basically use? What make? You would have to have signal generators, other test equipment.
Well, some of it was HP, and then some of it I used to make, this stuff here. This was a pulse generator and a voltage calibrator that John Beasley designed, and I made 3 of them. They're all handmade, and it produces a pulse in there. As you can see, it lines up with each line on the graticule, and it basically starts off with a 10 meg crystal, and it just has a heap of 7490s in there, and then it goes into a little integrator, and it gives you these little pulses. The other side has got a stabilised power supply, which is 100.6 volts. Now, the 0.6 volt is what you lose across the saturation of the transistor, and it goes down to about 0.2 of a microvolt. And that's what you use to set up your square wave. So every time you just go along here, and it's got one, you put that on 0.2 of a, and you can feed 1 volt in, and you should be displaying 5 centimetres. So most of the stuff they tried to do in-house because they had no money. So John Beasley used to keep telling me. Anyway, people, if there's no more questions, I'd like to thank you very much. I hope I haven't stuffed it up too much. No, we've got another question. Hang on, another one.
Charlie, I remember BWD making a device for tech schools. It was called a mini lab.
It was a mini lab, yeah. That was mainly designed originally for the PMG, and it was a combination. A lot of people here have probably got one. They've got power supplies inside them, plus or minus 15 volts.
Operational amp?
Yeah, they've got an operational amp, they've got a power amp. Some of the later ones had function generators inside. Now, function generators are horrible because they don't produce a good sine wave, because wherever the triangle goes up, that little tit up the top, when you've got your sine wave, you can always see it. It's always there. It doesn't look right. But you could alter it to have it, like a ramp or a back-to-front ramp, or you could do plenty of things with it. And that was pretty useful as well. But we were talking oscilloscopes today. Anything else? Yes, sir.
Back in the days of servicing at RMIT, I used to have a class of people who would make something useful. So we got a BWD 160 function Jenny and laid out the board, got boards made. Actually, it was part of the project. We did them up in our board lab. And the kids actually used to make a BWD 160 generator, and every one of them worked.
It was good. It was good. Yeah, well, that all happened after I'd left. I wasn't there. The latest one that I was there was when they built this 530. Then this one I've never seen. Half of all the green stuff, because I left, you remember 75 or something when I left, so I have been gone for, 40, not gone up here, but gone from BWD. So that was about it. But I've always been in contact with the company. Like I'd go down at least once every 3 months and show my ugly face, and they'd always show me around, this is the new model and this is what we're doing, and that's what, because I was very interested at the time. So then when they decided to close, one day Bob McPherson rang me up, he said, Charlie, come over and buy all our rubbish off us. So we took about, I don't know, quite a few utefuls of stuff all to my farm, and I've got transformers and knobs, and there was a lot of stuff that was incomplete, so I am now completing, because just having it sitting there and then people said, you're going to sell it? And I said, well, after I put about 1,000 hours into each unit, no. Okay then, thank you very much for listening. Thanks. Bye. If you want one of these leaflets of BWD, it tells you the story I've got plenty of them here, and they've got a copy of that valve, the V1 transistor replacement, on the back.
Thank you, Charlie. Great story about Australian industry at work. Now we're going to have a tea break, and you can look at all the treasures again up in the mini auction area. Thank you.
Yeah, but some of the lacquers then can attack the material. No, 525. Yeah, they had quite a few different blankets. But well, lately I went to use this one here, which I used for 20 years, I think. Switched on this one.
Some things I put those in places where there were templates at the top, and hopefully they'll last longer. So I try to find substitutes.
But then it depends on the circuit, I suppose.
Yeah, we see with some of these things, the tantalum,
You know, the old silver light.
they were the holy grail of reliable acid, but they electroplate through them.
Oh, okay.
Particularly if there's a DC voltage on there. I remember I was trying to code around the microcapacitors.
And it was, went on a,
Microcapacitors.